Hello, and welcome to The Atmosphere and Us. I'm Brenna, and today Danielle, Elle, and I will be taking you on a trip throughout the layers of the Earth's atmosphere. The atmosphere has 5 main layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. These layers are made up of mostly 3 gases: nitrogen, oxygen, and argon. The atmosphere is divided into these layers based on temperature structure. Temperature decreases with height in the bottom layer because it's the surface that heats due to the sun. Heat is lost with altitude and the decrease in pressure. Temperature increases with height in the stratosphere due to the chemical reaction in the ozone layer. Together, the layers of Earth's atmosphere work to protect the planet from greenhouse gases. As far as scientists can discover, Earth is the only planet with an atmosphere that's perfect enough to provide for life on the planet. Let's take a closer look at each of our atmosphere's layers. First up, we have Danielle with the troposphere and the stratosphere. Here's to you, Danielle.
Thanks, Brenna. The troposphere is located closest to Earth. It extends from the Earth's surface to about 33,000 feet high. However, in warm regions like the equator, it can be as much as 65,000 feet high, and in cold regions like the North and South Poles, it can only be 23,000 feet high. The word troposphere is derived from the Greek word tropos, which means change. This name represents the extensive turbulence and constant change in the weather within the troposphere itself. The weather we experience on a daily basis on Earth occurs mostly in the troposphere. This weather includes rain, thunderstorms, lightning, wind, tornadoes, hurricanes, typhoons, and even gentle breezes. Most of the dust particles in the Earth's atmosphere are found in the troposphere, as well as the water vapor, which is the reason why most of the clouds in the Earth's atmosphere are found in the troposphere. It is not heated directly from the sun. Instead, the sun heats the ground and ocean, and this heat is then radiated into the troposphere. The transitional area between the troposphere and the stratosphere is called the tropopause. This jet stream, or river of air, is located just below the tropopause and moves at approximately 250 miles per hour. The stratosphere is the second layer of the Earth's atmosphere. It starts about 7 miles from the Earth's surface to about 20 miles past. Unlike the troposphere, however, it is colder closer to the Earth and warmer the closer it is to the mesosphere. The stratosphere accounts for approximately 24% of the Earth's total atmosphere and also contains approximately 19% of the Earth's total atmospheric gases. The word strato comes from the Greek word meaning layer, which makes sense because 90% of the ozone layer is found in the stratosphere's upper crust. The ozone layer is an important part of man's survival on Earth, as it absorbs the UV radiation from the sun that would otherwise be deadly. We are slowly destroying the ozone layer because of our use of aerosols. The ozone layer is important because it helps us with the production of vitamin D, but with too much of it, we could be destroyed. Other cool facts about the stratosphere include that there are no clouds there due to the very little amount of water vapor. Airplanes fly into the stratosphere to avoid turbulence, and even some forms of biological bacteria can be found here.
Thanks, Danielle. Next up, we have the mesosphere. The mesosphere is the third layer from the Earth. Its name comes from 2 Greek words, mesos meaning middle, and spira meaning ball. The temperature gets extremely cold in the mesosphere. The coldest part of the entire atmosphere is at the very top of the mesosphere. This area is called the mesopause, which is the border between the mesosphere and the thermosphere. The mesosphere is somewhat of a mystery to scientists, and it is very difficult to send instruments there to study it. Satellites can't even stay in orbit due to high atmospheric drag. The rockets that are able to be sent into the mesosphere are called sounding rockets. The mesosphere is where most meteors burn up before they reach Earth. To the naked eye, a meteor burning up looks like a bright trail of light. This is what humans perceive as shooting stars. Something else that occurs in the mesosphere is sprite lightning. Sprites, or elves, are bright bursts of electrical charge that happen far above the clouds of thunderstorms. They appear as bright red sparks in the sky that can vary from giant groups or clusters to long and thin strokes. Clouds known as noctilucent clouds, or polar mesospheric clouds, form near the poles of the mesosphere. These are very high altitude clouds. Now here's Al with the thermosphere and exosphere.
The thermosphere is the atmosphere's 4th layer, located above the mesosphere and below the exosphere. It also happens to be the largest layer of the Earth's atmosphere, extending from about 56 miles to between 311 and 621 miles above our planet. The word thermosphere is derived from the Greek word thermo, meaning heat. temperatures in the upper thermosphere can range from about 500 degrees Celsius to 2,000 degrees Celsius, or higher. Typically, the thermosphere is about 200 degrees Celsius hotter during the day than at night, and about 500 degrees Celsius hotter when the sun is very active. The main components of air in the thermosphere are helium, atomic nitrogen, and atomic oxygen. The air density is so low in this layer that most of the thermosphere is actually what we normally think of as outer space. Both the Space Shuttle and the International Space Station orbit Earth within the thermosphere. Changes in the density of the very thin air at orbital altitudes brought on by the heating and expansion of the thermosphere generates a drag force on these satellites. Because of this, engineers must take into consideration the drag when calculating orbits, and satellites occasionally need to be boosted higher to offset the effects of the drag. One of the most amazing sky phenomena occurs in the thermosphere. The southern and northern lights occur when charged particles from space collide with atoms and molecules in the thermosphere at high latitudes, exciting them into higher energy states. Those atoms and molecules shed this excess energy by emitting photons of light, which we see as the colorful auroral display. The exosphere is the uppermost region of the Earth's atmosphere and fades into outer space. Not all scientists agree that the exosphere is really part of the atmosphere. Some consider the thermosphere the uppermost part of the Earth's atmosphere and think that the exosphere is really just part of outer space. The word exosphere is derived from the Greek word exo, meaning outside or external. The exosphere is almost as wide as Earth itself, at about 6,200 miles thick. Since the exosphere gradually fades into outer space, there is no clear upper boundary of this layer. Air in the exosphere is extremely thin, and the temperature varies greatly, ranging from 0 degrees Celsius to over 1,700 degrees Celsius. The exosphere contains gases like hydrogen and helium, but they are very spread out with a lot of empty space in between. Most gas particles in the exosphere race along curved paths without ever hitting another atom or molecule, and eventually arcing back down into the lower atmosphere due to gravity. Some of the faster moving particles, however, don't return to Earth, but rather leak away into space. Although the exosphere is the most distant layer of Earth's atmosphere, it's the planet's first line of defense against the sun rays, as well as the first layer to come into contact and protect the Earth from meteors, asteroids, and cosmic rays.
Thanks for joining us on a trip through the 5 layers of the Earth's atmosphere. We hope you learned something today.